Today, it's kind of nice because we don't have to just do math that has no context. We actually get to talk about some real world stuff. Like, for example, the price of eggs. Price of eggs has gone up a lot. And it's like, how much did it go up? You can figure out what percent it went up. Or in the real world, price of gas is kind of another big one. You go and you fill up your car and you're like, dang, that costs a lot all of a sudden. And you look at the price at the pump, and you can talk about it as exponential growth. So instead of just a graph that looks like this, and by the way, that one's growth, and decay looks like this black one here. Decay goes down, 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 down. Okay, and they both have an asymptote that's right there on the x-axis, which is y equals 0. All of those are actually can be real life situations. And that's what we're doing today is applications. So, by the end of the day, we'll be solving some real-world exponential problems. Now, I need you to understand a few things, though, that are just like basics. Do you remember what anything to the... Well, let's start with an easy one. There's 5 to the 1, but then there's 5 to the negative 1, and then there's 5 to the 0. Would you write those 3 out? And do you know all 3 of them? This is the part where the headphones need to come off. The cell phones need to go away. Give me your full attention here. Please try the problem that's on the board. Okay. All right. And I know most of you know these, but some of you are getting these wrong, and you think you know them, and you don't. And this would burn you on the test pretty bad. 5 to the 1 is 5, duh. But how about 5 to the negative 1? That is not half of 5. Yes. 1 over 5. That's right. That's 1/5. I like to say that it flips it. And if you're like, how does that flip? Well, it's like 5 over 1 in the first place, right? So then it flips to 1 over 5. All right, and how about 5 to the 0? 1. All right, one of the keys from yesterday was when you had this, you had to know that first you do this and then you put the negative on. Why does that matter? Because, for instance, kids always think that if you put it to the 0, well, you told us it's equal to 1. But it wouldn't be in this problem. Because why? Well, because this part is 1. And then later, you put on the negative, and it would become negative 1. Remind me to mark you back to present later. All right, so if you have a problem like this, which is exactly what we kind of did yesterday, would you be able to tell me the 3 things that it did? It was basically a this, which is an exponential growth, but then it moved 3 ways. This does something, and that does something. I saw Practice ACT the other day, and this was right on there. They gave a problem like this, and they were like, which way did it move? So please write down those 3 things. You can abbreviate them if you want to. Just remind yourself, what are those 3 moves? The 3 moves would be a vertical reflect, right 4. If you said left 4, I totally understand, because negative 4 is usually to the left, like it's over here somewhere. So why on earth is it right? Because it's inside. You don't trust the things on the inside. They're counterintuitive. All right, and then that 7 is up 7. You guys with me so far? All of those are like what we gotta know, like little basics we gotta know. Yes? Good question. All right, so just look at this for a second. Would you agree this is your typical exponential growth kind of graph? I'll show you. I'll get there. But if this is your typical exponential graph, then the equation for it would be y equals, let's say, 2 to the x. If I put a negative here on the outside, then that vertically reflects that, and it goes like this. You see how it flipped up and down? Okay, now if I put the negative not on the outside, if I put the negative on the inside, that would be called horizontal, because horizontal on the inside, you remember the high-vo thing? And it's in there with the X, then that one wouldn't flip this way. It would flip that way, which is like if you grabbed it with your hand right here, make this my fingers and there's my thumb, and I grab it and I drag it over this way, it would pivot on this point right there, and then it would rotate that way, okay? So remind me to mark you back to present later. All right, so this is the difference. If there's a negative here, then that's horizontal reflection. It looks like the green one when we're done. And I know that looks exactly like exponential decay, which is true. That's the difference between these two. The red one is exponential growth, and the green one's exponential decay. And the difference can be that you just put a negative in the power, or the difference can be if you used, isn't that like 2 to the negative 1 kind of, which is like 1/2? See, that's why technically when you put a negative on the inside, you're putting 2 to the negative 1 power, which is like 1/2, which is, that's decay. So it switches to one of these kind of graphs like that. Okay? So there's 2 ways it can flip. If it's on the outside, it's vertical. If it's on the inside, it's horizontal. All right, so I think we're ready now to answer these questions. I think without a little warm-up, you wouldn't have been able to do it. But can you find these questions? And give me a little example of a sketch of exponential growth. Don't overthink it. I just made you 2 of them 2 seconds ago. Make a sketch of what exponential growth graphs look like. And then right next to it over on the right, make a little sketch of what exponential decay looks like. And for your exponential growth function, just write y equals and then give me an example of one. The difference is growth versus decay. See, one of them's a picture, one of them's an equation. And then the third question is translations, which are moves and flips and that kind of thing. Can you make me an equation that's got 2 moves in it? See, the hard part here is just knowing what the question is. If to really understand what they're asking you, then it's not hard questions. You can make up any examples you want. Okay, here's the difference. Exponential growth goes like this. It goes up, not just a straight line. If you did a straight line, you're doing it wrong. Exponential is where it goes faster and faster and faster. That's the difference. This is called linear growth. You don't make a straight line. Don't make it straight. You got to have it curved like the red one. Okay? And then decay, that's where it's going down, 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 like that. Okay? And then what do they look like? Well, growth ones have a whole number down there, like 2 or 3 or 4, something bigger than 1. And decay, that's got like a fraction down there, something that's less than 1. Because when you keep putting in, like, let's say you put in 2 here, that means you're going to take 1/2 and do it twice. 1/2 times 1/2. And it gets smaller and smaller. Okay, so you have to have an x in the exponent to be exponential. Last but not least, the green questions. This has 2 changes. Oh, wait, I was doing a fraction function like last chapter. Oops. These are like exponentials like this. And then 2 changes. Well, if I do one change, it'd be like something in with the x. And another change could be like something out here. The one on the inside is the horizontal change. And the one on the outside is the vertical on the outside. So that would be an up 7 kind of change. Last but not least, a reflection. If you just put a negative in front of 2 to the x, that would do it. That's an exponential function that has a horizontal. Oh, wait, dang, horizontal reflection? I didn't even notice it said horizontal. Sorry. Horizontal reflection needs to go there. Did you catch that? Because it's different. Horizontal's on the inside. If I almost made that mistake, I bet you somebody else did. Okay. Good. Now we get to get into the real world stuff. Would you rather have $1 million or a penny that doubles every day for 30 days? How many of you have heard this problem before? All right. And if you haven't heard it, it is amazing. Of course, you would think that $1 million would be more because the penny just starts so low, okay? But if you do it for 30 days, you are going to be doubling it for 30 times. So would you agree that doubling it for 30 times is like that? Now, what's 2 to the 30? It's a lot. It's a lot. It's huge. In fact, take a second, grab a calculator or use the one on your iPad. You're going to actually need calculators a lot today. So if you're the type of kid who'd rather have it on your, like on your desktop, I pull out my calculator. If you want to use the iPad, it's totally fine. These aren't like complicated ones. You can use your iPad for it. But 2 to the 30. Do it on your calculator. On your iPad, it's fine. Take a second, actually do it. It's a lot faster than going 2 times 2 times 2 times 2 times 2 times 2 30 times, right? All right. Chase, would you read me the digits that it comes out to? It says probably 1.7 times 10 to the something, or... Haven't typed it yet? I'll come back to you in a minute. Please actually type this, everybody. It's not that hard. 2 to the power of 30. Liam, Frink, what digits do you have?
I have a whole number.
Okay. Read it.
1,073,741,824.
Can anybody verify that number? Yes. Okay, a lot of people are saying yes. Okay, I want you to process that for just a second. That one was in the millions. This is over $1 billion. So if you could actually find somebody who would be willing to do that deal with you, maybe our government's maybe that stupid, I don't know, $1 billion to give you your penny a day, doubling. Yes?
Wouldn't that be incorrect in starting at 1, not 2?
Ooh, excellent question. All right. So let's talk about starting value. The start value goes in the front. And would you agree I can put a 1 times in the front of it? All right. So if I put 1 times 2 to the 30, what that does, and this is getting right to I need to teach this to you in a minute. So this is actually not just a waste of time here to answer his question. This is called the equation for this. And this is where the starting value goes. And this is where your rate goes, which doubling is actually, here's what we're going to draw it as. You would agree that 2 is really 1 plus 1. That's the same thing, right? And this is the rate of growth right there. And that is 100% growth. And that's what doubling is. Doubling is 100% growth. It's not 200% growth. People get that wrong all the time. I've even seen that in like movies. Doubling is 100% growth. Because if you had 2 and you get 100% growth, you have 4. Because 100% of 2 is 2. So people think doubling is 200% growth. It's not. It's 100% growth. And so I do get what you were saying, that it seems like that would be wrong because I just had a 2 at the beginning. And it's like I started with a 2. But your start value goes in front. You take a 1. And then if I double it 30 times, that'd be my answer. Now, if you want to get technical with me, then maybe we should double it only 29 times. But would you agree it would still be a massive number? Okay, so if I started with a 1 on the first day, and then I wanted to get to the 30th day, it all kind of depends on how you want to word the problem. But maybe you argue that you didn't double it on the first day, you only doubled it after that. So, but there's an equation that you're going to see at the end of the hour, and I'm glad you brought it up. This is where you put how much you started with. And if you started with $4 and you did the doubling game, you just put a 4 here. All right, enough about that. The rule of 72. This is actually a really powerful rule that a lot of adults know, and I found that almost no kid knows this. And it has to do with people that are into investing. So if you aren't into investing or you aren't saving money, if all you're doing is just living your normal life and you're paying your bills, you don't use this as often. But if you're investing and you're trying to make your money grow and make it double, then a lot of times people know the rule of 72. So what it does is your money will double at 72 divided by the interest rate. So if you get 10% interest rate, that's an easy one to do in your head. 72 divided by 10 is 7.2. And what that means is, all you got to tell me is what interest rate I'm getting. And I can tell you how many years it'll take for my money to double. All right, so let's imagine a world where you have $200,000 saved up. And you want to know, how long is it going to take me to double my money? Well, 72 divided by whatever the interest rate is. 72 divided by the interest rate. Well, right now, if you went to the bank, they give you about 5% interest. 72 divided by 5 is how long it'll take that money to double. I want to see what the calculator says. What is 72 divided by 5? 14.4 years. If you leave it in the bank at 5% interest, it's going to take 14.4 years to double your money. Now, a lot of people are like, well, yeah, that's great, but my parents don't have $200,000. But what about if they just have a house? I'm going to make a bold statement. I don't know how many years it will be, but whatever house you are living in, even if it's an apartment, then it might be the rent that you're paying on your apartment, is going to double. Whatever your house is worth right now, it's going to double in value. It's going to cost twice as much someday to buy that house. It's just a question of how long it'll take. And so here is a typical interest rate for a house. 4% growth. Then all I got to do is that, and it tells me how many years it's going to take to double. What is 72 divided by 4? 18.
72 divided by 4 is 18.
18 years from now. 18 years from now, your house is going to be twice as expensive as it is right now. I know from experience, I bought a house that was $100,000. It was a long time ago. Now it's worth $400,000. You can't get a house anywhere around here for $100,000 anymore. So went from $100,000 to $400,000. And some of the houses around here went from $400,000 to like 1.6 million during that same time. They went up 4 times over a long number of years. So interest rate is also like how much your house appreciation rates are. So I'll give you an example of, I just bought a house in Colorado. I bought it, and the amount of money that I have to pay every month to buy the house is about the same as the rent that I'm getting on the house. Okay, so I'm kind of like breaking even. The house cost about $380,000. I didn't pay all of that up front. I just got a loan for it. And the amount of money I'm having to pay out every month is about the same as what my renters pay. So my question is, if it's 4% growth in Colorado Springs, which is where I bought the house, I can take 72 divided by 4, and that tells me how many years. And we just did that one a second ago. If you have a short-term memory, it's 18 years. Do you get in 18 years, my house that I bought for $380 will probably have doubled. Years to double. So that's going to be worth $760,000. And maybe, if I'm lucky during that time, I will have been able to raise the rent a little bit. You know, it's not going to stay the same rent every year, right? And so then I'll make a little bit more money, and maybe I'll get it paid off in 18 years. So then it's paid off and it's worth that much. So 4% is a number that I didn't just completely pull out of my head. It's actually a real typical rate that you can count on real estate to go up in value, like about 4% per year. All right, so I just thought you might find this formula for the rule of 72 interesting. And if you just remember 72, always 72, that's kind of one of the cool parts, divided by what rate it's growing at, that tells you how long to double. All right. Now this one, you're actually going to have to do a test question like this. You ready? I'm going to set this one up. Everybody start with y equals. The starting amount always goes here. You want to set up one nice problem so you have a good notes on like how to do this. The start number goes there. You always do 1 plus because her salary is going to grow. It increases, so I'm going to add. If I just times by 1, it won't grow. So I'm adding 4%. I hope you know that would be 0.04. Does that ring a bell? Does that sound right for 4%? Okay. And then you do it, since these are called exponentials, there's an x in the exponent, but we know how many years. It says right in the problem. How many years? How many years? 8. So you're going to put the 8 years right here. And if you know how to type on a calculator, that's all you have to know. You put the rate here, and you put the time here. Do you have one good problem written down like this? On this slide, if you copy this down, that's how you do the word problems involving exponential growth. Your starting amount, how much it's going up, and the time. This is not like the other one where it's how many years to double. That's just kind of a good in your head kind of rule that smart business people know. This one you have to know for your test. Put your starting amount here, the rate that it goes up, and then how many years. And then if you can type it in on a calculator, please, and let's make sure. If you don't get the same answer, you're doing something wrong. We need to know if you know how to put that in. So take a second right now and type it in. Do it. Last time, some people didn't actually type it. Type it. Take a second. You need to know if you know how to do this. Where's yours? You haven't typed it in yet? Okay, that's great. Except, yeah, numbers have changed a little bit. In a moment, I'm going to ask you to show me that it's on your calculator. because I seriously want you to type this in right now. If you don't know how, I will help you through it then. Please don't just write it on your iPad because you could have copied that from the kid next to you. I want to see it on your calculator. Again, literally you're just typing in the numbers in the red box. That's all you have to type in. And if it's on a calculator, then I know that you have figured out how to put it in. All right, I'm gonna swing past. Can you show me? Thank you. Thank you. Thank you. Nope. Nope, this is, something's wrong. I don't know what. Oh, 0.04, not 0.4. 0.04. Just a typo. All right. It's there? Good. You see it. Yeah, you know how to do it. There it is. Thank you. Thank you. Okay. Looks like almost everybody is typing in so far. I've just found a typo. Okay. And actually hit enter so I can see the answer. There it is. Good. Yep. 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 How'd you do it in your head? Did you have a calculator somewhere? I don't see the calculator. So that's why I wanted to see it in the calculator. Make sure you know how to type it. Thank you very much. Because you want to know how to type these in. These are like really supposed to be hard problems. They're not hard. If you know how to set them up, these count as like R3s on the test. Yay. Thank you. Thank you. Okay, cool. So, yay. Gotcha. You'll recognize this, the same thing we just did a second ago. Here's the official formula. The amount you'll get is the principal, in case they throw that word at you, that's the same as the starting value. Principal and starting value, same thing. Annual rate of return, that's a valid point. Everything's going to be in years. Nobody out there ever says, I'll give you 5% monthly. No, it's always annual. That's how our society pretty much works. We deal with annual interest rates. Okay. So currently the inflation rate is about 2% per year. I actually looked it up because I thought it'd be more interesting. It is at 2.9, but we're going to round it to 3% per year. Everybody change that to a 3. What is the current national average price of a gallon of milk? This is why Siri ought to be fired. It just brought up a movie called Les Mamies. That has nothing to do with the price of milk as far as I know. All right, hold on. I'm going to go to a different AI. What is the national average price of a gallon of milk? They've got to fix Siri. It's like an embarrassment. All right, the national average, it was $4.02, but we'll just go with $4. $4. So if it starts at $4, I don't want to care about 2025. I want to say if it keeps going at 3% per year and milk is $4 right now, I want to know in 4 years, how much will milk be? Hint, you just learned how to set these up 2 seconds ago. It's the same formula. This is awesome because you can actually use it in the real world. Did you know the starting amount goes right here? Always 1 plus. And if you said 0.3, I forgive you. 0.03, that is a very common mistake. 3% is 0.03 to the fourth. I actually want to know, how much is milk going to be in 4 years if inflation stays the same? Take a second, type it in. Did you get 4.5-ish? And a real person would say that is like $4.50, right? A bit, a rounding, but about $4.50. Okay, cool. You can see how this could lead itself to lots of real world problems. Do things always go up though? No, sometimes they go down. And the only difference will be, you buy a car, it goes down, it goes down, it goes down, it goes down. That's called exponential decay. It's the same kind of a formula. You start with your $30,000 car, and then you multiply it by 1. And I did say always up, because so far, it was only going up. But now we're going to say that the price of the car goes down minus. And from my experience, I'd say cars go down at least 10% per year. 0.10. And then the only question is, how many years do you want to do it for? Well, I'm going to just say, I'm curious because I bought a Tesla a while ago, and it's gone down in value. Every car does. Like if I brought a brand new Porsche, be worth way less 3 years later. Okay? Just that's what cars do. So I'm curious. I have owned it for 3 years. I'm wondering about 6 years. So let's go like that. Take a second. That's if car goes down 10% every year for 6 years, how much will it be worth? And 1 minus 0.1 is the same as 0.9. But I strongly recommend you type it exactly as you see it, because if you put it exactly as you see it, the calculator will do it right. Yes?
My mom is a conjurer, and she, most recent car was a collectible.
Ooh.
So it actually keeps going up in value.
That-
My dad is really annoyed by that because he bought a car and his car's going down.
Very nice. And I've actually, when I was young, I actually thought about buying a collectible car because I knew that that could happen. And that's a really good point. Not many people do that. You've got to drive a really old car. But if you drive a really old car that's kind of like a classic old car, that's one of the only cars that can go up in value. But of course, you're using it, so you're making it a little bit like more worn out over time. But so you have to use it very gently. But you could get away from this, like losing money on your car deal, if you do what your mom did and buy a classic collectible car, because they sometimes do go up in value. Now we're talking like some of the cars, you have to spend like $1 million and then like never drive it, and then it's worth $2 million later. But you can also do where you buy one that's not like $1 million car, but like an old Corvette, for example, really kind of a cool Corvette. It might actually slowly go up in value. It just kind of depends on what car values are doing in the collectible car market. Okay, so back to this. If you just type this in, what is the only difference? There's a minus there. That was it. Otherwise, it's the same exact formula. You just got to know if it's going down, you use a minus. And if it's going up, you're going to use a plus. All right, good enough. So let's see if you can take 2 seconds and set this sucker up. It should go super fast. Always start with the starting value. It's also called the principal in the business world. There's not many alwayses in life, but in this unit, you always start with a 1 in there. But you don't always do plus. If it's going up, you do plus. And in this case, it's going down, so you go minus. And I hope you know 17% down would be 0.17 to the 7th. We weren't even going to type it in. As I now know that you know how to type that in, and you know you would get an answer that is lower because it's going down. All right, good enough. I think you guys get this stuff. We got a worksheet on this stuff. I'll tell you which ones to skip. And that was getting close to being done with this unit. We're not done, but we have basically a couple more things to teach you, and then we test on this early next week. All right. Find the worksheet, please. I know that there are different levels of motivation in here. Some of you just want to like get through school, and you're going to be like, yeah, I'm not doing this homework. I just want to remind you that every homework assignment that you do or don't do, if you just do it and just do kind of an average job, your grade will about stay the same. That's really what happens. Your test sets your grade, and then if you just do your homework, your grade stays about the same. If you skip your homework, every time you skip your homework, it takes whatever your grade was and it drops it. So if you're averaging like a B on your tests, every time you skip a homework assignment, you just dropped your grade. How much? It depends. Depends on how many points I put it in as. It could be anywhere from 0.5% to 1%. So whatever your grade was, it just went down 0.5% if you just don't do your homework. So do your homework. Kids have this myth that homework doesn't matter. It totally matters. If you don't do any of your homework, your grade will drop 15% from wherever it was. If you had an 85, you'd be down to a 70 if you never did homework. So just do it. It doesn't take that long, and it's good practice. And I also try really hard to keep it reasonable for you. You know I cut tons of problems out of your homework to try to keep it reasonable, to try to keep you doing it. All right, so enough about that. On this Schoology quiz, there are 6 questions. I am going to chop out the last one. So the Schoology quiz, I'm going to just give everybody the answer for number 6. You'll all get a free point, okay? So you may want to write this one down. Instead of like crossing off number 6 and not doing it, it's a Schoology quiz, so you got to enter the answers. So I'm going to tell everybody that the last answer is 8464. There. Now I just effectively had you skip number 6 because you get a free point for typing in 8464. That's number 6. All right, so let's start with number 1. A car is valued at $5,000. I bet it's like this, because the starting amount goes there. Depreciates at a rate of 2.5%. Ooh, tricky. 1 minus, I could totally see some kid typing 2.5. That's a decimal. No, that's not 2.5%. Neither is 0.25. That's 25%. It's 0.025. So if you're like, how do you know where to move it? You take the decimal, you move it 2 spots. See, it was here. You move the decimal over 2 spots. And then it's to the, how many years? Oh, 3, thank you. If you type this in your calculator, it'll give you a decimal, and I want to remind you how to round. Your answer comes out to 4.634.2, and then what are the last 3 digits? 0.2 what? 6 what? Just keep going.
No, it's 968.
Oh, 968? 0.2968, is that correct? Oh, that's good enough. Okay, because they want it to the penny. All right. So this would be called cutting it off or truncating it. That's not rounding. Rounding means you look here. Would you agree that that's higher than 5? 5 and higher get to round up. So how do you round a 29 up? 30. That's the answer that you'd use. Just wanted to remind you, proper rounding. In the red box there. Okay. I hope you found that this could actually be seen, used in the real world. We did a little review. And now you got a very reasonable homework assignment. Don't forget to type in that free answer at the end for number 6. And that's all I got for you for today.